Hello everyone, it's Jennifer Albanese here at Spiral Ridge Permaculture. This landscape is our home and farm. We have been implementing Earthworks since about 2009, and we've experimented with many different types on different scales and for different purposes. We've had many successes, but we've also had, a few failures along the way. I wouldn't say complete failures, but they were all learning lessons and on how to do things better and what works in our particular climate. So this will be a case study of Earthworks here at Spiral Ridge Farm. So let's go see what we've got.
We are in southern Middle Tennessee in the southeast United States. Our climate is USDA Zone 7A. Our landform is comprised of ridges at about 1,000 feet elevation. Spiral Ridge is located on a finger ridge. Our road is at the top of the ridge and goes down in elevation as it moves towards the house. The land slopes down on either side of the road in both directions.
Here at Spiral Ridge, we receive about 57 inches of precipitation a year. That is well above average. We get all of our rain, though, usually in the winter and the very early spring, and we have very dry summers. We can have flood problems, and we can also have severe drought problems in the summer. We also have a susceptibility to fire. So our Earthworks planning, part of it was planning for catastrophe.
When we bought the land, there were no buildings, no trees, except around the perimeter, as it had been clear-cut. The lack of vegetation had caused soil erosion. Machinery left deep ruts in areas of compacted clay soil. Our first order of business was to stabilize the soil and prevent further erosion. We did this with earthworks and cover crops.
I think it's really important to discuss the terminology because I know when I was reading the permaculture books and studying and reading about stuff online, I was getting really confused because people were using the word swale in one way and they were using it in another way, in another context on another site. So let's clear up any confusion we have about swales to begin with.
Here in the United States, many engineers and builders use the term swale to mean a depression that collects and carries rainwater by gravity away from your home and property. They are meant to move water from point A to point B, like a diversion drain or a ditch, just that they are more broad and shallow. In permaculture, a swale is also a depression that collects water, but there are two key differences. The permaculture swale is built on contour, or rather at the same elevation, which allows the water to level out and sink into the soil. If you use a machine operator, make sure you are understanding one another correctly. The second difference is that permaculture swales also have a berm, and the conventional ones do not.
So all of our swales at Spiral Ridge are actually slightly off contour. What we wanted to do out here was a combination of a permaculture swale, something that's going to capture water, but we also wanted to move water. We wanted to move water so that we wouldn't get waterlogged soil. We wanted to move water to places where we could capture it in bigger systems like pond systems. And we wanted to move it really slow, not like your typical diversion drain, right? So we didn't want the water to rush away. We wanted to kind of slowly crawl its way towards the pond so that we had some infiltration and some diversion. As we marked our lines, every, let's see, maybe every 10 feet or so, we would go 1/4 of an inch below the contour line. The elevation would change as it went, and that's how it would move along towards the pond, but very slowly. And you can change that, if you want it to move faster, make the change in elevation greater or in a shorter distance. But the faster the water moves, the more erosion you're going to have along the swale walls and along the berm is also going to get eroded if you have fast-moving water. This swale behind me, or off-contour swale behind me, is a pretty large one. We built it with the idea, and we actually call it a twale. It's part trail and part swale. And the goal behind making it this big was that, we have a lot of rain water coming down the slope from this direction and continuing on down this direction. So what we did What we did was okay, so we have an orchard system down below the berm. So all the water that collects here passively irrigates our orchard system, which is kind of, in a zone 3, zone 4. It's not something that we want to run irrigation to necessarily. So this is a good system for keeping that area watered. So the water comes in mostly from downhill, and it also comes in from the road. And spills into this area and then makes its way to the ponds.
We are also experimenting with some terraced beds below this swale. Here you can see the path the water takes along the off-contour swale moving towards the pond. We initially built another pond that you can see over here that we later decided to fill in. We were rookies at the time and the pond was built wrong and didn't hold well, so we scrapped that project. Similar off-contour swale systems were also built on the other side of the road. Water collects off the road in various places, moves towards a pond, which then overflows into a bigger pond at the end of the driveway behind our house. This is again repeated on the other side of the road, effectively channeling water down into the pond from off the road. These large-scale swale and pond systems can also act as a fire barrier and be flooded in case we need to prevent the fire from going further up the hill towards the buildings. This was a very large undertaking requiring lots of heavy machinery and know-how. So this is an example of a broad-scale application of earthworks. Not all of our earthworks are successes. This large swale is not ideal. Notice how steep the sides are. Ideally, the sides would be no greater than 45 degrees because it's hard to establish vegetation at steeper angles. When you build earthworks, you want to cover the soil as soon as possible with vegetation or mulch to stabilize the soil. This swale didn't fail per se, but does not give us enough benefit to warrant the energy it took to build it. It is well below all of our cultivation areas. Medium-scale earthworks can utilize machinery but are also doable by hand. In this application, we've created numerous small ponds that we call pocket ponds. They are filled by constructing rolling dips on the road that slow and channel water into them. Rolling dips are essentially angled speed bumps. Each pond has rocks at the inlet to slow and filter water and catch silt, and also a level sill spillway to deal with any excess that cannot soak up and the pond cannot hold. We created these ponds to act as vernal ponds, which are essential breeding habitat for certain species of wildlife, including salamanders and frogs. They also capture and store water, mitigate heavy rain events, and act as wallow for our pigs when rotated through. This is an area where we created an agroforestry system. Agroforestry is agriculture incorporating the cultivation and conservation of trees. We built a series of off-contour swales that feed one into the other by snaking its way down the hillside. Each swale ends in a small pocket pond, which can overflow to the swale below. The berms are all planted in food forest strips, which are guilds of trees, bushes, ground covers, flowers, herbs, and any insectary species we need to attract beneficials. In between the swales, we have annual field crops. This is called alley cropping. The raised beds follow the slightly off-contour pattern of the tree systems. We also have a hugelkultur bed off-contour in the agroforestry system. It is much smaller than most and does not have water catchment in front of it. Combining hugelkulturs and swales can be problematic because the water can cause the buried wood to float and move down the hill and potentially cause some damage.
Here we are in the food forest. This is, a pretty small scale food forest. We did some hand dug swales and ponds in this area. This got planted, I think, 7 years ago. And so what we did was we created a small swale system. It's 2 swales and 2 little ponds.
Here is the site before the forest garden went in. We first dug a pond with a machine because we had one here for another project. We then created the first off-contour swale to catch excess water from the well and had it flow into another small hand-dug pond. The overflow from that pond goes into a second off-contour swale, which moves the water into the first pond that we built. These ponds function like a pocket pond without the pig wallers, and also provide habitat for ducks who poop in the water. That nutrient-rich water fertigates the forest garden. The overflow goes into a drain tile, which is that plastic tubing, buried in the ground, which transports the water further down the hill to the kitchen garden. This system is working pretty good, except we have too much water catchment during the rainy season, from the two swales too close together. The result is we have one area where the soil is too waterlogged. We have planted mint in that area as well as willows along the swale to help suck up the extra water.
Here we are in the kitchen garden. So like most of our land, it is sloping, and we've got a gentle slope moving down this way. This is the one area where we did do, on contour earthworks, and we did it to build raised beds. So the paths, are the swale area, and the raised beds are the berm. And we did this because we have pretty clay soil, so we wanted to create a system that would allow our some drainage in the soil, but that would also, passively irrigate. So we don't have any drip taper, and we hardly water this garden, to be honest. Like we water some seedlings in, but even in pretty dry times, it's worked well for us. And so all the water collects in the pathways, and, it seeps in underneath the garden beds. The plants soak up what they need, and any excess just keeps going down the hill towards that bench swale, and then flows down into the pond.
Water is a great connector. It's what forms relationships between many of our systems. Let's take a quick look at how they can fit together to create whole systems. Zooming into the agroforestry area, we have our first off-contour swale dumping into a pond. That overflows into another swale with a pond at the end, at which point it goes into the forest garden system. You will recall that system also has two small ponds and two swales. From there, the overflow goes to a swale above the kitchen garden and finally ends up in the bench swale and pond. That pond overflows into another large off-contour swale. Going back to the agroforestry area, we have two more swales and two more ponds that eventually guide the flow back to the large pond. We have several more collection points off the road that also direct the flow toward the large swale and pond. The water would have taken the path of least resistance down the hill and ended up in the same sink area. We just redirected and slowed its flow while absorbing and utilizing more of the resource.
So that wraps up our tour of Spiral Ridge's Earthworks systems. It's pretty extensive. We have a pretty unique situation, but I hope that you've been able to gain something by watching this video. Some ideas about what's possible, some pitfalls to avoid. Do your due diligence, spend a lot of time in the design phase instead of rushing into implementation with Earthworks. Do the mathematical formulas to find out how much rain you're actually going to be capturing in the landscape. How much rain do you really need to capture? Just make sure to cross all your T's and dot all your I's, and just go slow and small. Start with some small hand-dug earthworks and see how they work for you, and go from there. Wait until you get some feedback. If you're not feeling confident about doing bigger projects, then I think it's very wise to consult with someone who knows what they're doing, or get some further education on the topic. And make sure you communicate well with your operators. Make sure you're totally on the same page to avoid, making any, what I would call type 1 error, or something that could turn into a problem when we're supposed to create solutions. Thank you so much for joining me. We'll see you next time.